Hello all, good morning. Today we are going to discuss about OSI layers. OSI means Open System Interconnect. So most of the interviews you may get this question: what are the OSI layers? And what is OSI layer and what are those OSI layers? OSI was developed by the International Organization for Standardization, ISO. I think most of the people know ISO. Okay, and introduced in 1984. It is a layered architecture, consist sorry consists of 7 layers. Okay, each layer defined set of functions which takes part of the data communication. So this layer tells how the data is communicating, how the data is flowing within the network. In the network, how the data is flowing from one computer to another computer. And also, this is a very basic thing, how the data is flowing between one computer to another computer. Okay, let's check. So OSI, Open System Interconnect. OSI means Open System Interconnect. There are 7 layers. First one is physical layer, and second one is data link layer, and third one is network layer, and fourth one is transport layer, and fifth one is session layer, and sixth one is presentation layer, and seventh one is application layer. So these 7 layers will involve uh, in data communication. Involve in data communication. So how these OSI layers are involved in the communication, data communication. Let's see. So coming to first application layer. Sorry, application layer. What is application layer? It is responsible for providing an interface for users to interact with application service or networking service. So what is application layer? It is responsible for providing an interface for the users to interact with the application services or network services. So for this, I'm taking Gmail. Everyone is know Gmail, right? Let's take this Gmail account. So we'll relate the this 7 layers of each layer, how the data is communication between each layer from one computer to another computer. So let's take the Gmail example. Okay, let's take Gmail example. So first application layer. So what application layer? It is responsible for providing an interface. So this is the application. Gmail is an application. Gmail is a application. What this Gmail provides? Interface. What is the interface? This is the interface. Inbox, sent, draft. So there are many interfaces for users to interact. So without this interface, can we interact with the Gmail application? No, right? So without this interface, we cannot interact with, I mean, we means users. Users cannot interact with application. So for users, should be an interface. So then only users can interact. So this is the application. Gmail is the overall Gmail is the application. In the application, we have an interface, many interfaces to interact with the application services. Okay, so for example, HTTP. So Gmail is HTTP and HTTPS. Okay, so Gmail runs on HTTP, FTP, HTTP, HTTPS. So there are many application. So just I gave one example like HTTP. So this is the application layer. So application, Gmail is application. There are many interfaces to interact with the user. I mean, sending an email. Okay, you all knew how to send an email, how to interact with the Gmail account. So let's say Gmail is a application layer. Okay, application layer. Coming to usually applications, HTTP, FTP, SMTP, Telnet, TFTP. These are the applications which with these services users can interact. So the users can interact with these services. So that is called application layer. Okay. Next, coming to how the application layer data flow. So data flow usually on port numbers and services. I would like to tell you one thing, that in IT, information technology, every service has a protocol. Every protocol has a port number. So this is fundamentals. I mean, so every service has a protocol. Every protocol has a port number. So this www.google.com. www is the service, right? www is the service. www is the service. For www service, what is the protocol? HTTP. See, HTTP and HTTPS is a protocols. HTTP and HTTPS are protocols for www service. Okay, and port numbers 80 and 443 are port numbers. 80 and 443. Okay, that is a different story. So coming to how the data is, this is the application layer. Application layer, users are interacting with the application layer. So the application layer, how the application layer data flow on port numbers and protocols. Okay. So the data is, see, this is a Gmail is the application, and here are the data. This is the data, right? So data flowing, how the data flowing from application layer to presentation layer. Let's see. Next, presentation layer. It is responsible for defining a standard format to the data. It deals with the data presentation. So presentation layer. So Gmail is an application, but presentation. See, if you see the presenting inbox and sent items, draft, and many more. So these are the presentation. So data Gmail is an application. In application, data is presenting in a different ways, right? So this is all data presentation. So Gmail is an application, so it is an application layer. But the data is presenting inbox, standard, sent, default, snoozed, starred. So there are many ways to presenting the data. So these are all the data presenting in various ways. So that is called presentation layer. Presentation layer is nothing but providing data in a different format and different ways. So coming to here, so text, graphics, voice, video, and all. Encryption and decryption. Encryption and decryption. For example, when I'm sending or receiving a data from one Gmail account to another Gmail account, so what will happen? Between, one second. So for example, so you are sending data. You're sending data from one machine to another machine. So what will happen? Encrypt and decrypt. So this is a sys1, sys1, sys2. So if you're sending data from sys1 to sys2 or sys2 to sys1, what will happen? Data will encrypt and decrypt. Why data will encrypt and decrypt? So if you don't encrypt and decrypt, I mean, so when you're sending a data from sys1 to sys2 over the internet means it's a public network. So if you don't encrypt the data while sending the data to sys1, sys2, there are chances of sniffing your data. There are chances of sniffing your data and they may hack. So you make sure you you encrypt and send it to S2. So S2 will decrypt and understand the data and respond to S1 and decrypt the data and respond to S1. So encryption and decryption will happen always. Otherwise, over public network, if you don't encrypt the data, there are chances of sniffing and after that, chances of hacking the data. So encryption and decryption will happen in presentation layer. In presentation layer, compression and decompression also happened in presentation layer. So compression, decompression. If you sending the best example, compressed data will copy quickly, uncompressed data copy slow. So when you're sending a data from S1 to S2, data should be, for example, this is data. This data should be decrypted first and then compressed, and then you need to send to sys1 or the internet. So once this it receives S2 system, S2 system, if respond to S1, then S2 first encrypt the data and compress the data. Both, if you compress the data will uh, reach fast. So compression and encryption is both are needed. Encryption and compression, both are important. So while sending the data, you should encrypt and compress the data. So coming to Gmail, so we are not compressing the data, sir. We are just sending the email. That's it. No, you no need to compress. You need to encrypt the data. So there is an HTTPS. This will take care your encryption the data. Compression. So when we are sending an email, you need to, I mean, most of the people, if it is a single file, sometimes sending without a compression. So that takes a lot of time to load in the destination side. So if you compress the file so that it will load very fast in their inbox. So that is your choice to compress the data, or if you want to send the compressed data or uncompressed data, that is your choice. But encryption will automatically encrypt and decrypt the data because you're using HTTPS. HTTPS means secure. This will encrypt and decrypt your data and both ends. So basically presentation layer presenting the data in application. So this is application. Gmail is a overall is a application. Okay. Gmail is a application. And in the application, presentation layer is presenting the data in a different formats like text, JPG, and video and text. So there are different ways the presentation layer presenting the data in the application. That is called presentation layer. So you can see voice, video, graphics, text, all. And also in presentation layer, data will encrypt and decrypt, compress and decompress. This will also will happen. Okay. Okay, fine. Now data is flowing application to presentation layer. So in both places we call data. This is the data, right? This is the data. If you send items, these are all data, files and text, mails. So mails, this is also text. So these are all data. Okay. Coming to session layer, it is responsible for establishing, maintaining, and terminating the sessions. Session ID used to identify sessions or interactions. Session. What is the session? Okay. Most of us experience the Gmail session. If you, for example, if you open a Gmail in any system, then you open in any other mobile or tab, so that Gmail will intimate you that because the one more session is already opened in the machine and is going to open in another machine. Are you, are you, or someone else opening your Gmail account? So this is a session. So when I log into the Gmail server, this is my session. If I log out, what will happen? Session will close. Session will close. So this is my session. If you log into the your Gmail account, see, this is all your information. This session will not accessible to anyone. This session will not be accessible anyone. You can only access this session. And if you want to close the session, sign out. So that means you are closing your session. You are closing your session. Session is a logical thing which you can only log into the session. So in the session, you have a application, Gmail application, and presentation. All the data is presenting in different ways. Okay. So this is called a session. This is called a session. In other ways, we can call log into the server, and your log into database. If you're log into any application, so session everywhere. See, session is, without the session, you cannot log into any application. What is session exactly? See, I'm just interacting. I'm just logged into the Gmail server. This is the Gmail server. So Gmail server gave this application. So I use the application and generate the data in generate the data that is called presentation layer. So in this session, I'm maintaining my data. So if I close, the connection will close between server and client. So let's say this is Gmail server. This is Gmail server. This is my system. I logged into Gmail in my system, gmail.com. So I logged into gmail.com. So what will happen? A session will be created. Let's between server and or the internet only, or the internet, between server and client. So this is the session. This is session. This is my session. This is called session. This is session. So I'm taking the example of Gmail, but without these 7 layers, you cannot assume. You cannot assume that you cannot do anything. The 7 layers will involve in every action. In every action. Okay, so that is a session. Coming to how the data is flowing from application to presentation, presentation to session. So in application layer, we have seen the data. Presentation layer, the data in a different form ways to present. Okay. And session layer with data flow between this session. Server to client. This is client mission. Let's say this is client. Client means our mission. Client. So data will flow in this session. Coming to transport layer. So transport layer, in the name itself, we can understand that what is transport layer. It provides data delivery mechanism between application in the network. It provides data delivery mechanism. In this session, data will deliver from server to client, client to server. In this session, data will deliver. So what are the data flowing here that will be encrypted and compressed? That will be encrypted and compressed. In this session only, data will be delivered from server to client, client to server. Okay. So what the transport layer the major functions described at transport layers are identifying the service, multiplexing and demultiplexing, segmentation, sequence and resembling, error correction, flow control. This is a big uh, topic. So how the data is flowing. So we never know how the data is flowing backend. We are just seeing when you are sending an email, whether it is sent or not, when we are receiving an email, whether we are receiving or not. That's it. But behind the screen, backend, how the data is flowing. So I'm taking just example Gmail. That's it. But every action, that action, these seven layers will uh, involve in every activity. I mean, every data transfer activity, these seven layers will involve. Without the seven layers, we cannot transfer the data. Okay, so I'm just taking the example, Gmail example. That's it, because you all guys are all know very well about Gmail. Okay, so coming to how the data is transport in the transport layer. Let's see. So identifying the services. Identifying services is done using port numbers. I already told in the previous class and before also. So the system will identify protocols and port numbers, because when the request comes, the system will try to understand that the request on coming on which protocol, on which port number. Then only system can understand. Otherwise, system cannot understand. Okay. Port is a logical communication channel. It's a logical. Port is a protocols, ports, it's a logical services. And these are the total port numbers. This is the entry question, 0 to 65,535 total port numbers. In the total port numbers, reserved port numbers 1 to 49,151. Okay. So, and open ports are 49,152 to 65,535. These are reserved ports, means these ports will used by the systems. These are the open ports. You can use this port numbers. Okay. So multiplexing and demultiplexing. So what this multiplexing and demultiplexing? See all the port numbers. Let me show you. See, for every action, see, for every activity, there is a port number. See, these are all services running. So this service is running this port. See all. Whatever I'm using the services, without the port number, system cannot understand. Okay, so these are all back-end process. You never you never see that. These are all back-end. Whatever you're doing, that everything will be uh, processed, and system identifying and um, identifying the events, your actions based on the port number and protocol. Okay, so coming to multiplexing and demultiplexing. What multiplexing and demultiplexing? See, TCP IP, UDP IP. So these are the protocol suites, TCP IP and UDP IP. I'll tell you in upcoming classes what exact TCP IP and UDP IP. These are the protocol suites. Okay, TCP means transmission control protocol. IP means internet protocol. UDP means user datagram protocol. IP means internet protocol. These are the protocol suites. We call proto suites. We call protocol suites. On these protocol suites, there are many protocols will work. What are the protocols? HTTP. So in TCP IP, HTTP is a protocol. This protocol work on TCP IP, FTP, and HTTPS. Okay, so these are the protocol. Many protocols are there. We cannot list down now. So there are many protocols, etc. There are many protocols will work on this protocol suite, on TCP IP protocol suite, and UDP IP. UDP IP also DNS, DHCP, and etc. There are many protocols works on UDP IP. So few protocols works on TCP IP protocol suite. Few protocols works on UDP IP protocol suite. So this is protocol suite. Under the protocol suites, there are many protocols working under this protocol suites. So here coming to multiplexing and demultiplexing, because which protocols working on which protocol suite, that is called multiplexing and demultiplexing. When the request comes, for example, I sent mail. I sent a mail. Okay. Test. This is the data. If you want to attach the data, you can attach that. So this is the data I'm going to send. I'm going to send. So let's say this is the application. Gmail is application. In the application, compose presentation layer, because in the presentation layer, compose is a interface to send data from here to from source to destination. Okay, so send. If I send, what will happen? First, in presentation layer, the data will be encrypted and compressed, and this data will send to destination, right? And session layer, what will happen? The mail will travel in this session and reaches this destination in the session layer. Okay, fine. But how the data is reaching exactly what I'm sending? See, here I'm sending like this. It should be reached like this only. Otherwise, it should not reach, like, for example, okay, welcome to transport layer. Okay, so hello, how are you? Thanks. So whatever I'm giving the sequence, the data I'm putting the in sequence, the data should be received in the same sequence to the destination. From source to destination should reach the same sequence. So if, for example, if data not received in sequence, what will happen? They cannot understand the data. So the way I'm putting the sequence, putting the data in a sequence, the same sequence to reach the destination. Okay, then only they can understand. Okay. So this multiplexing and demultiplexing, what will happen? So conversion. Oh, this is TCP/IP. This is UDP/IP. So protocols works on between multiplexing and demultiplexing, and single TCP/IP convert multiple. Uh, so I already told you that this is protocol suite. On this protocol suite, these protocols will work, right? So that is called multiplexing and demultiplexing conversions. For example, this is a HTTP. So what protocol should work? TCP/IP. So this is conversion between, that is multiplexing and demultiplexing. Conversion. Oh, this is HTTPS. This is, oh, this is mine, TCP/IP. Oh, this is DNS. Oh, this is UDP/IP. So UDP/IP, TCP/IP will multiplexing and demultiplexing. Conversion. So identifying which protocol suite, that is the service using which protocol suite. Okay, that is called multiplexing and demultiplexing. Okay, next, how the next TCP/IP. I told you, right? Transmission Control Protocol, use a Datagram Protocol. Okay, so read this. This is a connection-oriented protocol. This is a connectionless protocol. Connection-oriented means when you call uh, some service, the service should be acknowledged. For example, ping. I already discussed ping www.google.com. So I'm calling Google using ping command. So it's giving response to me. So when someone you call, if they didn't respond, that you thought that they didn't listen you, right? But in TCP/IP, that is called connection oriented. When you call google.com is responding that yes, I'm receiving your packets. So ping is a TCP/IP protocol, works on TCP/IP protocol. So this is connection oriented. Connectionless means, so there is no acknowledgement. Whatever your data sending, the data will not acknowledge that I'm reaching, I'm reached. Nothing will acknowledge. Support acknowledgement, no support acknowledgement. That is what? No acknowledgement. Reliable communication, unreliable communication. Because reliable means you're not sure whether the data is reached or not. But here reliable, because make sure the data is reachable. So protocol number is 6. TCP/IP use 6, UDP/IP 7. These are the protocol suites. On this protocol suites, many protocols working like HTTP, FTP, SMTP. On UDP, DNS, DHCP, TFTP are many. Okay, okay, fine. So segmentations. Segmentation is the process of dividing application layer messages into small chunk of known as transport layer segment. So the Gmail is ready. Now, if I click send, it will send. But how the data will cut it, cut will cut into pieces. That is what? The message into smaller chunks, small pieces. The data will be cut in a small chunks, and it will travel. I mean, it will go in the session. It will go in the session. Okay. But if you cut the data into smaller chunks, how the data will receive? So that is sequencing resembling. So when you reach the destination, see here, hello, how are you is the data. So the data will be cut it into pieces, cut into pieces like this. Okay, but if this piece is reached first, and if or this piece reached first, then what will happen? Need to sequencing. Okay, the data will cut it into pieces and it is traveling from source to destination. But if you data is not sequenced, then what will happen? The destination users could not understand, right? So this is the sequence. The data will travel like this. And sequencing means the data will be reached in a sequence, though it is traveling in a not unsequenced way, but when the data is reaches in a sequenced way. See, hello, how are you? This reached sequence. That is what resembling. Resembling. So here in the transport layer, if you observe, in the transport layer, what will happen? Identifying the service first. It identifies the service and multiplexing and demultiplexing, segmentation, sequence and resembling, error correction, flowchart. Then only reach the data destination. So all this will happen in the transport layer. So each one identifying the service. First, what is the service name? The service works on which protocol suite? The service divided into bits and pieces, and sequencing and resembling. So it should be, the data should be in a mm, sequence way, and resembling and assembling and resembling. So this is segmentation. Sequencing, see like this, the data will sequence. So this is total uh, pieces. So total pieces 5. So it's given number 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. So this is a sequencing. So the data will make in sequence order and resembling. Data will resemble. So next flow chart. Flow control, sorry. Flow control messages the amount of data that can be sent before receiving an acknowledgement from the receiver. Error control and correction. Ensure the data received at the receiver end in the same as the one sent by sender. Flow control prevent data overflow at the end. So source to destination, if you're sending the data, it should not be overflow. It should not be unsequencing. So what will, these are all control. So we are just sending an email, but backend, these many things are working. What are the things are working? Identifying, servicing, multiplexing, demultiplexing, segmentation, sequencing and resembling, error correction, flow control. So these are the things are working back, and that is the reason you are able to receive the data exactly what you send. Okay. So data should not overflow from source to destination. See, this is flow control and error correction. Ensure the data received at the receiver end is the same as the one sent by sender. What the sender is sending, the data exactly reaches the destination. Okay, the same sequence, same way the data should receive destination. Okay, so from application layer, presentation layer, session layer, transport layer. So data in application layer, we call data. Presentation layer, data. Session layer, we see the data. But the data will cut it into bits and pieces, small chunks. That is called segment. The data will become a segment in transport layer. Okay. And coming to network layer. What is the network layer? It provides a logical address and path determining routing. Okay. Coming to here. So that in the session layer, data is sending in is using transport layer, it is sending. But for transport layer, who will provide the path? Who will provide the path? That is network layer. Network layer providing the path to the data. Providing the path to data. So it provides a logical address and path determination. Routing, that is called routing. The protocol that works in these layers are routed protocols. IP, IPX, AppleDoc, etc. Routed protocols are used carry user data between the host. Yeah, so the data is coming through transport layer, okay, but to show the path to the data, where to reach, that is network layer. That is network layer. So I send, what will happen? Application layer. From the application layer, in application layer, used presentation composed, and I composed a mail in a presentation layer and add some data sending to session layer through session layer. This is session layer. In the session, sending the data through transport layer. But the transport layer taking care of the data should be reach the same sequence, no issues, no overflow. Data should not overflow, data should not loss, and data should be in a sequence mode in a session layer. Okay, transport layer will take care. But who will show the path to the destination? So to the transport layer, network layer is showing the path to the transport layer where to reach. That is called network layer. Okay. So in the network layer, we call protocols, IP, IP address, logical address. Okay. So if you see here, data in application layer data, presentation layer in data, session layer data, but the data will become a segment, and the data in a segment format and become packet. When you're coming to network layer, it become a packet. It become a packet. So next, data link layer. It has two sub layers, MAC address, media access control. It provides reliable transit of data across a physical link. It provides error detection using CRC, cyclic redundancy check. Example, Ethernet, ping. And LLC, logical link control. It provides a communication with the network. So this data link layer, okay. So in the session, transport layer, transporting the data in a correct order, and the network layer is showing the path to reach the destination. So data is reached destination. Okay. So when you reach the destination, data link layer will start working. What the data link layer do? Data link layer converts that data packets into frames. Frames is a unit of data that transmit over the data link layer. So data is on a network. Now it is data link layer. So data link layer land the data on a physical layer. Land the data on a physical layer. So the format of landing the data on a physical layer is frames. So now the packet data converts the frames. The data will become a, see, the data is changing various, uh, changing the format and behavior based on the layers. So this is data only, but when the data is in application layer, data. When the data is in presentation layer, data. Session layer, data. But when the data comes to the transport layer, it becomes a segment. And when the data is coming to network layer, it becomes a packet. When the data is coming to data link layer, it becomes a frame. Okay. Now, finally, this data will landed into physical layer. Physical layer is nothing but mission. In the mission, it will land at application layer only. So that is also one more application here. Okay, landed into physical layer. It defines and electrical mechanism and functions, specifications for communication between the network devices. The functions described at this layer are encoding and decoding. It is a process of converting the binary data into signals based on the type of media. So the data on data link layer, it is on network. So on the network, the data, what are the data on the network, that is landing on physical layer. How the data will land on physical layer? See, electronic signals and different voltages, fiber media, okay, lights pulses of different wavelengths, wireless media and radio frequency. So the data now it comes a bits, frames to bits. The data stores in bytes and bits, right? So finally the data landed in physical layer in a bit format. So this is encapsulation, decapsulation. So this is the source, A computer, this is the B computer. From A computer sending the data to B computer. Okay. So in application layer, from application layer to presentation layer to session layer, transport layer, network layer, data link layer, physical layer. So it go to physical layer. So this is encapsulation and this is decapsulation. So finally, the data will present in an application only, not a physical layer. See, if you see the data will in application layer, presentation layer, it shows that it present the data. Session layer, sending the pipe in a pipe. Session is a like a pipe, virtual pipe between computer A, computer B. So the data will transport in a segment, bits and pieces. And the data will, in coming to network layer, when the data is carrying by the network layer from source to destination, the data will become a packet. And when the data is finally reach the destination, the data link layer converts into frames. So from the data link layer, it lands the physical layer, computer, in bits and bytes. This is how data is flowing. I'm just took the example of Gmail, but for every action, for data transportation, that is what here clearly saying. Each layer defines set of functions which takes part of data communication. When you transfer the data uh, from one computer to another computer, these layers in the network, these layers will function behind the screen. Without these layers, you cannot transfer the data. This will not visible. This will work backend. This will work backend. So in this class, we are got to know how the data is flowing backend behind the screen and what are the layers involved in various stages. The data is in various stages. The stages are 7. These stages are involved in a data communication. The stages is nothing but layers. These layers will help the data communication smooth from one computer to another computer. So you cannot assume the data communication from one computer to another computer in the network without these 7 layers. So definitely there is an entry question about OSI model layers. So you have to tell in interview that what is application layer. So application is nothing but the data, where the data is stored, where the data is generated. Okay. Then presentation layer, data will present the data in various formats like text, JPG, image, text, video, audio. The data will present in this presentation layer. Session layer, the data will flow the session. The data will load, the data will travel in this session. And coming to transport layer, the transport layer will take the data, uh, take care of the data sequencing. So for example, if you take the one thing and put the thing in another place, exactly whatever you are carrying and placing in another place, there is no disturbance in the data. Transport layer will take care the data transportation, whether the data should be not disturbed and should be in a sequence order when reach the destination. That is transport layer. And network layer to show the path the data. So the data reaching to destination, but who will show the path? Network layer. So network layer take the data to destination. And data link layer, when reach the destination, the data on the network, the data will be stored on physical layer, that is hardware. So the physical layer stores in the hard disk. Physical layer is nothing but hard disk. Okay, it stores in bits and bytes. That's all about OSI. Any questions? Any questions? See here, comparison between OS and TCP IP model. So without the TCP IP model, I mean TCP IP and UDP. Okay, so data is flowing. Application, presentation, session, that is called application. Transport layer is a host to host transport. Network layer, that is internet. Data flow on internet or intranet. And the data link layer and physical layer, it is network access. So leave it this, don't get confused. So this is the way encapsulation, recapitulation. Data is storing from source to destination, destination to source. So any questions? Any questions?
No,
Oh,
sir.
okay. Hope you understand this. If any questions, let me know so that I can clarify. So this is a very important, but this is not a visible thing. This is invisible thing. But without these layers, that there is no data communication. Okay. So it is a good to know these OSI layers because we should know what's happening behind the screen, how the data is flowing. We should know. It is a, if you know this layers, that helps to understand more in the computer. First, we should understand how the computer's behavior, what is the network behavior, how the data is transferring from one place to another place. So just even layman can know that if you send an email, you will get, and if you copy the data from one place to one mission to another mission, the layman can also copy the data. We don't need engineers to copy the data, but we are engineers to know how the data is flowing back end. We should know that. What is the difference between layman and engineer? So if you know backend, how the data is flowing, how the data is reaching, that is the difference between layman and we, engineers. Okay. So these OSI layers are very important. I'll send you this document. Just read it and watch the video again to understand more about OSI layers. Okay. Thank you all. Thanks for joining. Have a great day. See you tomorrow.
Thank you, sir.